and y is equal to some value of t. So x and y are independent of each other, but they're both dependent on the same variable, which in this case would be t. Neither of these are the independent variable. We're not graphing like usual. We're graphing a path. Um, the independent variable in this case is time, and z is really just, some coefficient of time. Because let's say you threw it at 100 meters per second in the y direction, it'd be a vector with a magnitude of 100. Then that'd be 100 times time, which would be, say time is 2, and you're, okay, 100. I'm going to just substitute this. And 2 times 100 equals 200. So you travel 200 meters in the y direction. This is still in the tabletop. Um, Let me erase this and restart with another one. So assuming that y equals some function of time, and x equals some function of time along the x and y axis. And we know that gravity is only pulling down, or it only has some effect on the y-axis. We can say that y equals t minus some value of g, and that x simply equals t some value of v for velocity. Vx for the velocity along the x direction. Just a moment. I can't do this quite right. Just put a line there. Okay. So x equals time times the velocity in the x direction, and y equals time minus g, v times time. Y equals vy times time minus g, or the force of gravity. That's what g stands for. So you'll notice that we have two different variables here that we haven't quite accounted for yet. We have the velocity along the y-axis and the velocity along the x-axis, and we'll assume that we only know the magnitude of this vector, or the velocity that we shot it at to begin with. Say the initial velocity, vi, we'll show that as, equals 100 meters per, that's a 2, per second, equals 100 meters per second. How is that shared between the x and y axis? Well, if either of you guys, if not either, any of you people, hopefully not either, if any of you people have taken trigonometry, or, know it somehow, you know that if we have a vector with a or this is just a velocity. I'm just showing velocity as a vector for those of you who don't know what a vector is. It's just a vector is anything with a particular direction and a length, or a magnitude. Now the length would be the distance traveled in time, say. For every increment of time, we get some increment in the x and y plane. So let's say that the length of this vector, the magnitude of this vector, is 100, just meters per second. I'm just writing 100 because it's easier. What value along the x-axis and the y-axis would that correspond to? You know what? I'm going to switch to a different color, just to keep it exciting. Yes, I know for some of you this seems a bit simplistic in that I'm going through it a little too slowly, but this is for those of you who are new to this sort of thing. So x and y. Now, where was I? Okay, so we have the vector with 100. Now, for those of you who also don't know what a vector is, every vector is made up of two components. Unless you're in 3 dimensions, and you have 3 components, 4 dimensions, 4 components, 1 dimension, 1 component, which is just the vector. In this case, we're working in 2 dimensions, so it has 2 components, which would be the the x vector and the y component vector. We're going to call those y roof. Wait, now. Sorry. The y unit vector is symbolized by y roof, and the x unit vector is symbolized by x roof. Hopefully you guys can see that. Oh, I have this turned. Okay. Hopefully that wasn't like that for too long. I'll pull you guys in closer. Okay. X roof and Y roof. Now, let's say this is at an angle of fish again, or alpha. What we want to find is the velocity that it travels in the x direction, or the component of the x component of this xy vector, which is this thing right here. This vector. Okay. Now, if you've ever worked with vectors, you know that we simply take the magnitude and say okay, let's say that, sorry, let's say that this green dotted line here is, say, f vector of x. No, let's call it just vector f. Not vector v. We'll call it vector v for velocity. The vector vi equals the not vector, equals v of x times x roof, which is just 1 unit in the x direction, 1 unit in the y direction. So because we don't actually have a mathematical definition for a dimension in this case, it really is kind of an intrinsic value on its own. But what we do is we add the x component times the unit vector in the x direction, and the y component, vx and vy, times the y direction, times the unit vector in the y direction. And that gives you a vector of vi. Now, you'll notice that if this is at any angle, you have a 90-degree triangle here, because I could draw something like this, or this, or even this. But what that lets us do is, seeing as it's a 90-degree triangle, all we need to know are two components of this triangle to find the other two sides of this. You know that when you add vectors, you go head to tail. And when you go head to tail, that forms a 90-degree angle. So there's always going to be a 90-degree triangle. Once again, if you guys have taken geometry, which I hope some of you have, otherwise this is going to be a very, very long video. All you need to know to find this side of the triangle, if it's the right triangle, is one angle, preferably this angle fish, and the length of this side, which I'm just going to redraw this as a triangle. Angle fish 100. All we need to know is this angle fish and this length of this velocity vector. And you'll notice that, seeing as this is a 90-degree angle, this would be the component vector. Sorry, not unit vector. Component vector in the x direction. So v of x and v of y. And I assume this would be v of x, y. I think we understand this now. So, I'm not going to go through and explain all of trigonometry at this point. Let me just rearrange this. So what I'm going to do is I'm going to skip a few steps. And let's see, x value. And say, there we go, okay. Angle fish, velocity vector of 100, is say that the v of x equals the cosine, equals vi cosine fish. I think I'll write that a bit neater, because I'm not quite sure if it's showing up. Oh, wait, no, it is. Okay, so Vx equals Vi cosine of the angle. So if the angle here were 45 degrees, we'd go cosine 45, which I think is like 0.7017 something, but 0.7017. Then multiply that by the velocity, which is 100. So let me just get a calculator. I'll do this quick example. Just a moment. Ah, here it is. This is not a wireless headset, so okay. So let's say we're firing it at a fish value or angle of 45 degrees, and that would be Vx equals. So now the initial velocity, that's this vector here, would be the magnitude of this vector, sorry, is 100. So I'd go 100. Those look like peas. Be 100 cosine 45.